Hello, everyone. This is Nick Brandolione. I'm a solutions architect out of Boston, and today I'm going to be talking about removing undifferentiated heavy lifting out of your Jenkins Build farm. And if you don't understand all those terms, don't worry, we'll be going over it. And at the end, we'll also have a demo. So first of all, you might hear this term quite a bit, undifferentiated heavy lifting, and it is a fairly famous quote from our founder, Jeff Bezos. And really the idea behind it is that in business, in life, in many things, there's just a huge amount of effort to keep the lights on. In some estimates, it's up to 70% of an IT budget, energy and spend is simply keeping the lights on. And just imagine a world where that 70% can be flipped and keeping the lights on or the undifferentiated heavy lifting is really only 30% of your time. And all of a sudden, now you have 70% of your time to put into adding value to your business. That type of flip is very powerful. And it is really the philosophy behind many Amazon managed services, because we believe that we can make it easy for our consumers, our customers, to do a lot of IT tooling using our managed services. And the tooling is such that you just turn it on, you let us worry about it, the patching, the upgrades, the scaling, the elasticity, and we'll just give you this tool that just works. And that's what most customers want, and they're generally very, very happy using our managed services. So today, when we talk about Jenkins, Jenkins is the premier open source build tooling. We're going to be talking about an aspect of it that we believe that Amazon can provide some value to, and that is going to be the actual build process. And we'll talk about that as we go forward. So I'm going to be talking about Jenkins. And if you're not familiar with Jenkins and you want more depth than I go into in this webinar, because we only have so much time, there is a white paper. It was produced in 2017, so it's fairly recent. And the link is on the top of the screen, and you can do a Google search. There's a PDF version, and there's also a HTML version. So feel free to go there. Many of the ideas I'll be talking about today are outlined in depth in this white paper. When I talk about Build and Jenkins, it really very quickly goes into the agile methodology and CI/CD. These are concepts that have been around for a relatively short amount of time in the DevOps space, less than 10 years for CI/CD tooling and pipelining, and Agile itself is less than 20 years old, depending on how you classify it. So these are relatively new, but really what it means to the developer, to my end user, is that they have the ability to push code from the developer's laptop into production in a much quicker manner than they could in the past. This makes things like code updates actually more reliable, the ability to do it quickly, and the ability to roll back if necessary. It also makes it much easier to add value, because the fact is, once your software is in production or even in development in a quick manner, you can move on to the next bug fix or the next feature request. So the fact is, businesses require their software teams to move faster, and the tooling and the culture and the methodologies now support that. So as an example, here at Amazon, our tooling and our culture has been well documented, and you should look up 2 pizza teams if you haven't heard the term. And basically that is the Amazon philosophy to keep our tools, our DevOps teams very small. We should be able to feed them with 2 pizzas, which is, maybe 8 to 12 people, depending on how hungry they are, but relatively small. And that size really is optimal for communication and for education and getting things done. So we have these very small teams, but we have many, many, many of them, all working on different aspects of our ecosystem. And because of that, you can see that our pace of innovation, if anything, has been rising at almost an exponential rate. In 2016, we pushed about 1,000 new products and services out our pipeline, and that's about 2 or 3 a day. And we actually do something like 1 to 2 changes in our software code base every second. Obviously, we're a very big company. We've spent a lot of time in optimizing our pipelines, but even small companies can benefit from the methodologies and philosophies that are behind the Agile movement and CI/CD and be innovative and agile as well. So software development has typically 4 major phases or cycles. And some people will actually add a little bit more, and sometimes they'll combine some of these, but this is very, very common. The first phase is clearly your source code, and it will almost always start out in a GitHub repository, being the most popular, but some other SCM repository. The developer will have it on their laptop. They'll be working on code. They push it into their source code repository when they're finished, and they'll put a message into the commit. Once they've done that, the next cycle is the build cycle, and that is simply we need to compile the code. There are languages out there that are interpreted, and there is no necessarily build phase, but they would still be put in this phase because the fact is you still have to run the interpreter, and more importantly, you have to do the testing, which is the next phase. And the testing could be things like your unit tests. They can be integration tests. These days, what's actually quite interesting to me is that I've seen more and more companies do things like load tests, where they'll build the software and they'll make sure that it's performing at or better than the previous version in terms of its performance. There are even customers who will do a security test, some sort of static analysis on the software, making sure that they haven't introduced any security bugs. And then the last phase is the, in this slide it says production, but the point is it can be development or QA, but you put it into a deployment phase where it gets pushed out, where someone can actually test it, sort of what it would be like in the wild. Again, QA, development, or ultimately production. So these are the 4 cycles that are most common in the software build phase. And today, we're going to talk quite a bit about how we can optimize the actual build phase, because that's the one that's most time consuming. And anytime you're trying to optimize a process, you should look for the outlier, the component or the part that is taking the most amount of time, seeing if you can squeeze that down, and you'll make a big progress in improving the optimization and performance of the cycle. So we're going to talk quite a bit about the build cycle. That being said, all the others, source, build, test, and push and deployment are important, and I will be touching on them as well. The build here is, I'm just going to go through the slides, but as mentioned, we check in the source code, we compile it, we test it, and then we deploy it out into our production cluster. Now, it's also very common in the vernacular of CI/CD to say that quite a bit. Oh, CI/CD, CI/CD. I'm building a CI/CD pipeline. What does that actually mean? So there are actually 3 common terms, and most people use them very lax. And I'm not going to split hairs, but you should understand that CI/CD actually means several different things. The CI part is the continuous integration. That is simply from committing my code, it will be built for me. And that is sort of the minimal threshold that we have to provide in a tooling, whether it's a 1 or 2 man small shop or a very, very large enterprise. You have to support at that minimal level the CI part. If you can't keep a handle on your repo and you can't build code as it's checked in, you're just not going to be able to take advantage of the rest of the tooling. Now, continuous delivery, which is the CD part, again, can be continuous delivery or continuous deployment. Most people mean continuous delivery, and that is basically where we take the build artifact, we push it through some perhaps advanced testing, as I mentioned, not just a unit test, but some sort of integration testing, performance testing, security testing, what have you. And then there's a gatekeeper. That gatekeeper is usually a manager or maybe a software team lead, and they will basically have the authority to say, okay, this code has passed our tests, we're going to now release it into production. That's probably the most common release process out there. Most people are not quite at the continuous deployment phase, where the entire process from begin to end is entirely automated. And more and more companies are getting to that phase where they simply allow developers to check in code. It gets built, it gets tests, and it will get pushed out. Now, I have many customers who, while they do support that, the actual deployment is done in a canary deployment so that they have a very minimal footprint in case there's something wrong with the code. So they'll allow the code to be pushed out into production automatically, but they won't necessarily allow the entire production cluster to have that new code. They'll test it in a canary cycle, maybe for 15 minutes, maybe for a few hours, and then if it seems to pass, then they'll push it out to the majority of the cluster. Also, we're not going to talk about it, but clearly if you have these automated tools to push out from commit all the way out to deploy, you do need tools or at least some sort of mechanism to roll back. If you make it easy to move forward, God forbid there's a mistake, you should have it easy to roll back to the last committed code base. Now, in terms of these major cycles, Amazon offers tooling and managed services that should help in all aspects of this. Really, the only part that we don't have a dedicated service is the testing, and that's simply because unit tests and performance tests and static analysis are very, very unique at this moment to the environment and the customer. And perhaps one day we will, but for now we have very solid managed services for code pipeline, which is the end-to-end setting up of the software release cycle. We have CodeCommit, which is basically our private GitHub repository, and it lives in your VPC. We have Codebuild, which again we'll be talking about how Codebuild integrates with Jenkins today, further on in the webinar. And then at the deployment cycle, you'll see Code Deploy. But other people will also use other tooling. Doesn't necessarily have to be Code Deploy. It could simply be part of the code pipeline, which might push it onto a ECS cluster or a Docker cluster, or might wrap it into, simply push it into a Docker repo. So each one of these cycles have other, we'll say, third-party tooling that you can use if you don't want to use the Amazon versions of it. Obviously, we're going to talk about Codebuild, but Jenkins can do the building, Solano CI, TeamCity, Atlassian, many, many companies can do it. By the way, in terms of Jenkins, I should also mention that Jenkins has an enterprise version that is handled by CloudBees, and there are many, many partners that Amazon works with which have solutions in terms of the testing, the integration, and the CI/CD pipeline. Okay, so now we're going to talk about how to build and test your application, and we'll get a little bit more into the Jenkins part and the typical pipeline. Now, before we get into those details, this slide is simply about how do you run your compute on top of Amazon, and this will impact our decision on how we want to use our build services. So most customers are well aware of on-demand. That is what the sort of default, and you can almost consider it as the list price for running compute on top of AWS. Whenever you click on the launch an instance, unless you do something else, you're going to get the on-demand price. It's a published price. Everyone knows what it is. It's published by region, and it depends on the size of your instance in terms of compute and memory and storage. If you know that you're going to be using the machine for a long period of time, so it's not a spiky workload, but it's a committed utilization, I just need this machine up running all the time, then it's worthwhile to look into reserved. Reserved is when you will pay up front some portion of your commitment, and for that, AWS will give you a discount. And the discount will range from 50, 60, up to 70% of your on-demand price. So clearly it can be very beneficial to use the reserved model, but only if you know that you need these machines for a long period of time, because the commitment is a minimum of 1 year, and we actually also have 3-year commitments. And it is a commitment. So unlike most things which are on demand and monthly, you do this 1-year commitment, and if you don't use the machine, you're still going to end up paying for it. So you have to make sure that you really are going to use those machines. But for that, you're going to get a huge savings. However, the last column for Spot is really quite interesting, and even sophisticated customers don't always use Spot, and it's a shame because it's actually the greatest savings, cost savings, here at Amazon. You can get up to 90% off your on-demand price, which is huge. Now, basically, Spot capacity is unused capacity in our regions, in our availability zones that no one's using, and because no one's using it, we basically say, well, we'll make it to your benefit to use these resources by giving you very, very inexpensive pricing into the compute. Now, what's the downside of Spot? Why wouldn't I use Spot? 90% savings sounds pretty good. Well, the reason you might not want to use Spot is because if someone wants that machine and is willing to pay the on-demand price for the machine, they're going to preempt you. So I'm working on my machine, I'm saving a lot of money, I'm doing a great job, I'm real happy, my boss is happy, my CFO is happy, but all of a sudden my machine literally goes away. I get a 2-minute warning and the machine shuts down and someone else basically gets access to those hardware resources. That may not be good. That I may have lost some computation, that was a long-running job, or simply it's a workload that just can't suffer that type of interruption. So therefore, Spot is not useful for all workloads. You need something that can be interrupted. Potentially, maybe it's stateless is probably a best way of saying that that's really what you're looking for. I do have customers who use it regardless, and they look at the 2-minute warning, and if that happens, they will actually save everything off to maybe S3, and they can afford to lose the machine. But you do have to be aware of that. And here we go, 50 to 90% off your on-demand. So really a good price. And I love that. Everyone should try it. Everyone should try it. It really is a great way of leveraging one of the strengths of the AWS platform, which is its scalability and elasticity. You can really, if you can get 10 machines for the price of one, and you can arrange your app to be handle the interruption, you know what, that's pretty powerful. Now, in terms of customers who use Spot, Lyft, obviously, I think most people know Lyft, the ride-sharing company, and they use Spot, and they're very happy, and they regularly save 75% over their on-demand costs in the past. And clearly, they've put a lot of effort into making sure their apps are redundant and resilient to a Spot interruption. So they didn't get there overnight, even though they were only able to change a few lines of code and all of a sudden they can start using Spot. It did take some time to architect the apps. Okay, so why is Spot relevant to the build process? Well, as discussed, Jenkins is the most popular open source tooling for building your pipelines, your CI/CD pipelines. And the way Jenkins works, it's a relatively old system. It was came out around 10 years ago. Is that Jenkins is a master system. Unless you do something otherwise, everything is done on the single master. The master handles all the configuration code. It handles all the pipelines. It does all the builds. It does everything. And that's fine if you have a small team. But what happens is when you start to get a slightly larger team and your code base starts to increase, you'll find that your build times start to lengthen. You start to get into a build queue if multiple developers check in, and Jenkins has to build multiple builds at the same time. I easily heard stories where the queues will back up for hours. And in terms of customer or developer satisfaction, if you have to wait for hours for building your code base, that's not making you agile. It's not making you happy with your job. You want to see your code built and deployed as fast as possible. So one of the things that Jenkins can do is that it can offload the build process to other machines, and this is quite common. And in the past, you might actually have a fleet of machines that were simply your build fleet. Well, today you can basically offload that work to a spot fleet. And for the price of a single machine, you can basically get up to maybe 10 machines that can be your build fleet. And that is one of the strengths of using AWS and Jenkins together. And I should notice that the strength of Jenkins, besides being the most popular one, is that it has these plugins. So if you haven't used Jenkins, and I'll show you in a few minutes when we get to the demo, they have many plugins, and one of them is this spot fleet integration. So the plugin just goes in, you configure a few things. I've put the links there on the Jenkins wiki if you want to find the details, and there's actually also a Jenkins blog about it. And you can go there and spin up a large fleet, and one of the nice things is when they're done, even though these fleets are very inexpensive, they will eventually tear themselves down as well. So one of the Jenkins plugins you should definitely investigate is the Jenkins Spot Fleet plugin. One of the other plugins that I'm going to talk about is for those who use ECS. So ECS is the Elastic Container Service, and it is Amazon's orchestration and management for people who are doing containers at scale. And I would say that, again, we're not going to talk about it in great depth, but one of the great changes in the last 4 or 5 years in the DevOps world is that more and more customers and enterprises are building their software using containers. Containers being popularized by Docker are really wonderful in that you build not only your code, but all the dependencies that go along with your code in the same artifact called a container. And therefore, when you tell someone else to spin up the container, you're confident, 100% confident that if it worked on my laptop or when I ran the container, it's going to work on yours, or it's going to work on the production server, because there's really no difference in the code. The code's the same, the dependencies are the same, the libraries are the same, and it really makes containers very, very, very powerful. So one of the other plugins is the ability to, after the build, is to push the built container into our repository, ECR, which is Elastic Container Repository, which is a Docker compatible repo, and then ultimately pushing it off to an ECS fleet of machines. So yet another Jenkins plugin that you should look into. If you use Docker, you'll be very happy with it. And the build cycle, which I'm going to talk about next, can also be used with this plugin. You can use multiple plugins in your pipeline. All right, so this is where I'm going to talk about Codebuild. Codebuild is the tool that I think makes most sense, the plugin that makes most sense with Jenkins. Codebuild is a fully managed build server that can work on its own. It can work with other Amazon tooling like Code Pipeline, or it can work with Jenkins. And if you have this Jenkins pipeline or this Jenkins CI/CD, and as mentioned earlier, Jenkins is going to want to build everything on top of itself in the master. And that's, unless you're very, very small shop, it's really just not going to scale. So what you can basically tell Jenkins is to offload all the builds to the AWS Codebuild service. So as mentioned, it's a fully managed build service. What's nice is it's continuous scaling. So let's just say I have, I don't know, I have a dozen developers working on a project, and they happen to all check in their code, their branches at the same time. And I have 12 builds to do right now, because we have, let's just say we have, worst case scenario, 12 different branches, no merging. We're just going to build all the branches at once. Codebuild will spin up, 12 build servers. In reality, it's going to be 12 containers. We actually build it in a container. But the point is, we're going to build as many or create as many containers as necessary that Jenkins asks for. If you have an enormous development team of 100 and they all ask for 100 builds at the same time, we'll build 100 in parallel. And once we're done, we'll shut down the containers and the charges for using the service will go away. So you're only charged, like most Amazon services, for when you use it. It will scale up as you need it, and it will scale down when you don't. So it's pay as you go. It's extensible. As mentioned, it works with Jenkins, but it also works with Code Pipeline. It works with Atlassian and other tooling out there just as well. And it is secure. At the end of a code build, it will create a compiled artifact, which by default is going to be put into an S3 bucket as an encrypted blob. And so, God forbid, the S3 bucket was left open. No one's going to be able to use the blob because it's been encrypted. So a nice peace of mind built into the system. Okay, so how does Codebuild work? Well, I'm going to show you a few examples in the demo. I'm also going to go over in detail what we call the spec file, which tells Codebuild how to work. But basically, here are the 4 steps from high level. It downloads the source code, and the source code can be in an S3 bucket. It can be in a GitHub or a CodeCommit or another SCM service that we integrate with. Then we execute the commands. The commands are something that you, the customer, have to create. We do have examples, and if you search the web, you'll find many, many examples of how to set up the commands. And then when we're done, we're going to stream the logs out to our CloudWatch service in case there's a problem. And if you wish to get notified if there's a build failure, you can integrate with CloudWatch. And I have various customers who also use plugins to grab the logs and put it into some sort of Slack channel to be instantly notified. And then, as I mentioned earlier, we're going to take the compiled code and we're going to upload it to an S3 bucket. Now, very often, Jenkins or Code Pipeline or some other system will simply automatically take that artifact and then we'll pass it on to maybe the testing phase as mentioned, or push it out to deployment. So this is simply what Codebuild does. But again, Codebuild is really part of a suite of tools, some open source if you wish, some AWS native that will work with it seamlessly. Okay, so just a refresher or a recap. So again, we need the source code, and the source code is not something that Codebuild handles. Again, it has to integrate with other services. It can also have a build trigger. Now, a build trigger, not something that many of my customers use. The trigger that they most often use is when a developer commits code into their GitHub, but it can also have a trigger where it's like a cron job. We'll just say, hey, Codebuild, once an hour or once every 10 minutes, check this repo and just build it for us. You can also do that, but I think most customers prefer it being triggered off of the external webhook of GitHub or Bitbucket. Codebuild will then grab that code as mentioned. It will scale up as necessary, and then it'll spit it out as an output artifact. So this is really just a summary of what I've been talking about. So easily pluggable. So in terms of both Jenkins and Codebuild, they are pluggable. Codebuild, as mentioned, can be run in terms of pipeline. You can use it independently. You can run it from the command line. You can run it from the CLI. Like all Amazon services, it's API driven. So again, you can take the commands and you can embed them into not only Jenkins, but many, many, many other services. You do have to tell the Codebuild system about the environment. That is, are we compiling C++ code? Are we compiling Go code? So it knows what type of environment to take your source code and wrap it in for the build process. Now, I always get the question, so let me just say, what if we're working on some strange language that we don't have a driver for? We're using, I don't know, Haskell, and you guys don't have a Haskell build. What are we going to do? Actually, it's quite easy. We do accept custom-built containers because, as I mentioned, we're actually not spinning up machines. We're spinning up containers, which we embed your source code into and do the build cycle. So if we do not have a pre-configured container for the environment or source code that you're working on, you can create your own. And in that container, you'll have your tooling and your compiler and anything else that you need as part of the build cycle. And you just point us at that container. We will use it, and then we will put it on a machine that will run the container with your source code. So it's quite flexible. If we don't have the environment that you guys are using, you can bring your own custom environment. The next question I get is the size. You said, there's a difference between compiling 500 lines of code and something that's 5,000 or 50,000 lines of code. And I'll just mention that we provide 3 different sizes in CodeBuild. And I don't have the specs in front of me, but we basically will just call them small, medium, and large. And we provide different compute and memory resources. So if you're doing a very big job with 50,000 or 500,000 lines of code, you're definitely going to want to use the large container version. And if you're using a small job, you're going to also want to use the appropriately sized container, a smaller one in that case. Okay. Now at the bottom is the link to the plugin for CodeBuild. It is on GitHub, and it was actually built by AWS, although many of the other plugins that I mentioned have been built by customers or third parties. So feel free to also look at the others. I've seen plugins for Lambda. I've seen plugins for ECR, as I mentioned. The Spot ones. There are many AWS plugins. This one, though, happens to be built by AWS. Okay, so this slide may be hard to see, and it's well documented, so we don't have to go over what everything does, but this file, this buildspec.yml, has to be on the top of your directory structure of your source code, basically in the root. Now, if you don't want to have it there, it is optional, and you just have CodeBuild have a copy of it, and basically when it grabs your source code, it's going to insert the file into the top level directory because it does need to read the specs and the configuration. So it is up to you whether you want to have the spec built into your source code or simply in the system. But either way, we do need some configuration information on basically how to build your source code. At the very top, you'll see a versioning, and you'll see a whole bunch of YAML here. Environmental variables that you can pass in. But most importantly is the phases, and you'll see that there are several here. There's install, pre-build, build, post-build. And each one of these phases is something that happens sequentially, and as you can imagine, you can do different things. For example, install, when I think, yep, there we go. Under install, we are updating our build environment, and in this case, it's a Java code, so we're also installing Maven, which will handle the dependencies. Pre-build, there happens to be nothing in this particular case, but then we have the build, which is kicking off the Maven install. Post-build, there actually is nothing in this example, but a post-build could also be a series of unit tests that you want the build artifact to be tested against, and that would be very common. And then at the very end, you see the artifacts. It zips up the compiled files. It puts it into a directory structure, and it puts it into the S3 bucket by default. But again, the other tooling out there can override it, grab the artifact, and use it in another component of the pipeline. So CodeBuild and Jenkins equals happy developers. I have a quick story. I was talking or listening to Adrian Cockcroft, who came from Netflix, works for AWS these days, and they've built a lot of open sourcing tooling, which they've very generously donated to the community. And he said one of the tools that they built was called Spinnaker. And Spinnaker is basically a CI/CD type of pipelining tool, very similar to Jenkins. And I asked him, well, why did you create this Spinnaker tooling when you had Jenkins? And he said, well, first of all, Jenkins was amazing, but but it was so flexible. We ran into a lot of what he called Jenkins abuse, and therefore they wrote their own tooling, which was a little bit more rigid and prevented that. So the strength of Jenkins is its flexibility, and so many times I hear that are there any distractions or detractors in Jenkins, and then sometimes you'll hear its flexibility. I would say if you use it right, it's an awesome tool, and if you use it with Codebuild, it's even better. So this is the most common architecture that I recommend to my customers for when they use Jenkins and Codebuild. So basically, we simply have your development team. They might be using CodeCommit. They might be using Bitbucket. They might be using GitHub or what have you. But the point being is they have a source code repo, which Jenkins can then pull. The Jenkins is going to be running as an EC2 instance most of the time. As I mentioned, Jenkins sort of came out before containers were popular. It came out, I think, about 9+ years ago. And so most Jenkins servers are actually Jenkins instances. Once the pipeline gets kicked off because a developer has put something into their source code repo, Jenkins will take it, and then it will pass off the actual build cycle, as we talked, to the Amazon Codebuild service. And at the end, it will pop it into S3, but again, it might go back into the Jenkins pipeline, and Jenkins might push it out to a container, or it might use Code Deploy or some other service to continue the end-to-end pipeline story. But this is the most common architectural overview, and it's really quite easy to put together. So this is how it works from a Jenkins point of view. We have the master Jenkins server, which is that Jenkins instance, which I showed you on the diagram. And then every time it gets a new build in its queue, it's going to basically talk to Codebuild, and Codebuild will create a new worker. And it will create as many workers as it needs to. Now, from a practical point of view, every Amazon or AWS account has service limits. So if you did have some crazy build number, 100 builds, you might run into an error simply because Codebuild will complain, but we can always raise those limits. So there is some practical limits you have to keep in mind. Same thing for Spot or maybe some of the other plugins. But in practice, you can really have as many worker nodes as you like. And again, when the worker nodes are done with the build, they'll either shut themselves off, whether it's Spot or the Codebuild plugin, and you won't have to maintain the expense and the maintenance of maintaining all these worker nodes. They come and go as you need them. All right, so I am going to do a quick demo of what I've been talking about. Most people learn more by doing, and unfortunately this is not an interactive webinar, but the next best thing is to watch me do. So let me just slide over to another screen. Hopefully everyone can see this screen. I am looking right now at a Jenkins instance. This is a vanilla Jenkins instance. I just put the Blue Ocean plugin for the UI, which makes it a little bit nicer. But otherwise, it's entirely vanilla. And I added, the only change besides the UI is I did add the plugin, which I talked about. And I created a project here called my Code Build Demo. I'm going to click on it. And you can see that I've had many, many builds. I've had 22 runs. And actually, most of them have been failures because I was just testing out some code. And I had some problems in my own code. This is actually a Go binary. And even though it's very small, my development skills are somewhat weak these days. So right here from Jenkins, you can see that there's a button that will run the process, and it will just kick off the build job immediately. But before I do that, let me also show you another way of kicking off the job. I am going to go into CodeCommit. CodeCommit is basically GitHub, right? It's a private GitHub. And you can see I happen to have my Hello World Go file here, and I can make edits. I can do pull requests. I can, do all sorts of things right here. I can click on it. You can see the code. It's not very complicated. I was having some problems with copying it over, and I couldn't figure it out. But anyway, let's make a quick change right now. I'm going to do a major change here. I'm going to add another exclamation mark into my code. And at the bottom, I'm going to do a code commit message. That's simply how code commit works. Like most GitHub repos, you do want a commit message. And I will commit the change. There we go. I've edited, it's been committed. Obviously, I could have done this on the command line, but I just thought it was easiest to show here. Now, the way this actually works is that when I set up my Jenkins machine, I have it poll once a minute the code commit pipeline, or the code commit repo. You can set up webhooks. You can make it a little bit more interactive, but this particular plugin has a very easy interface for a poll. So that's what I did, and I'm going to show that configuration in a minute. So it's going to take maybe 30 seconds, hopefully not a minute, but it's going to poll. It will see the change, and then it will start the process. So let me go back up here, and I'm going to go over into, I'm going to go into Code Build. Okay, so this is the Code Build pipeline, and you can see that I actually have many projects here, but and as I mentioned earlier, there were 20 some odd builds, and I have a history of the last few. Okay, and you can see that the last one I did yesterday, and the build actually only took 30 seconds, 20, 30, 40 seconds at most. So when we go back up here, I'll give it another few seconds. If it doesn't kick off, we'll just start it manually, because we do not want to watch paint dry. All right, guys. I don't know about you, but I'm an impatient human being. But so I'm just simply going to hit the run button. You can see I started a run, and it was started by me. But I can assure you that the webhook trigger works if I was just willing to be patient. Okay, so we have a run that's being kicked off by Jenkins. And we can see now on Code Build, I have an in-progress build. So in real world, Jenkins was either given a code commit of some sort from a repo, or maybe just like I did, someone has manually kicked off a build. And what Jenkins does is, under the hood, it's talking to Code Build, and Code Build is basically saying, please build this project. And you can see what time it started. You can see a link that you can give to people, which will take you right basically to this screen. You can see the actual logs, and you can see the artifacts once they're built. As I mentioned, it goes through an S3 bucket. All these things are actually also available in the Jenkins UI as well. And as mentioned, it takes maybe 20, 30 seconds, so we'll just flip back and forth between the different screens, but it should be done very shortly. Oh, and it looks like it completed. So let me go click on the Jenkins UI, and as I mentioned, it shows you all the logs, and you can see that it downloaded the code and was successful. Installed anything it needed to. That was successful. I don't think there's anything in pre-build, and then it went on to the build phase. Okay, and then at the end there was a post-build. Again, I don't think I had anything in my post-build phase, but you could have your UI tests and such forth and so on right here. So everything is finished successful in the pipeline, which is great. All right, so let me go back. And I'll go back to Code Build, and I'll refresh. And you can see it succeeded. And again, we can go to the logs, we can go and look at the artifact, or we could watch the link there as well. And it takes me right into the S3 bucket. And this is the code build artifact, which was just built a few seconds ago in a zip file. Okay, now that was Jenkins working with code build, very, very easy. I'm going to show you the configuration as well. Let's go back actually up here. And for whatever reason, when I click that button, it takes me back to the old UI. But here we are. This is the code build demo in Jenkins, and on all the sort of knobs I had to turn. I just let that all in the top the same. Down here, which source code? I said I was going to use Git, and I gave the repository URL, which was actually the CodeCommit, and I gave it some credentials. These credentials I created in IAM. If you're not familiar with IAM, that's the Identity and Access Management that AWS uses, and you can create users, and you can actually create GitHub credentials, and that's what I did, and that's what I used here. The build trigger, as mentioned, I simply pull once a minute, but you could use GitHub triggers or other things that are even faster. And then down here in the build environment, that's where I use the integration for code build. Again, I had an access key and a secret access key. I actually generated a Jenkins user for this in IAM, but the fact is I could actually leave these blank. And that might be something you may want to consider. And that's because the Jenkins server is actually on an instance, which has its own access keys that are available through an instance role. I don't want to go too far afield here, but in terms of security, you have the option of basically creating a dedicated Jenkins user or controlling access through the instance itself. And then I had a few other things. Which region am I running in? What's the name of my source code repo? And a few other things. And here are where you can basically also configure the code build setup. I left everything blank, and I did that in code build independently, so that you just realize you do have to configure code build independently of Jenkins, and you're basically telling Jenkins to use that code build configuration. So there's actually nothing here. All right, all the configuration is in code build. And let me go back. Oh, I see. Yes. If I were to edit the project, it would show you all the details that I did have to configure it. The name is pretty standard. I had to tell it Golang, which is the environment. I also had to talk about security and digital certificates if I needed that. Where do I want to put the output? And there's a few other things I also had to create, but really pretty straightforward and well documented. Okay, with that, I'm going to head back into the slide deck, and I think we are wrapping up. So one thing that I do get questions on, and it's partly because I am also a container specialist here at AWS, is, how does Jenkins work with Kubernetes? So I just put this together. Well, Jenkins can work just fine with Kubernetes. You can run Jenkins as a container. It probably works better, in my opinion, as a dedicated instance, but it can certainly run in a containerized environment. I will mention that Jenkins has also has this Kubernetes version called Jenkins X. I don't have a lot of personal experience with Jenkins X. It seems like it's pretty heavyweight. From Jenkins X, it will build its own Kubernetes cluster if you wanted to. So it's extremely powerful. But there's also other ways if you're using containers or Kubernetes. In particular, you can use code build, almost identical to how we just did it a minute ago, where whether it's using Jenkins at the front end, but it can talk to code build, which when it's built, instead of making an artifact that's on S3, it will simply put it in the container repo, and then we'll have a Lambda function kick off a process where the repo is basically passed over to the Kubernetes environment. This diagram is from a blog post that came out earlier this year. and Jenkins can be in the middle of this, and it's very much just taking what we've done and move it into the container universe. I will say that most sane customers or rational customers who have a great deal of experience in this almost always have a pipeline of some sort, CI/CD pipeline, which will build the container and might even turn it into what's called the Helm chart, that being a package manager solution for the Kubernetes world. So however you want to slice it with Jenkins or other tooling, you will very often still need a pipeline management tool. All right, so that's really it for this webinar. Just a reminder, please look at CodeBuild. I didn't talk about it in any depth, but also look at Code Pipeline. Very often, customers will not use CodeBuild by themselves. It will almost be integrated with either Jenkins or Code Pipeline, which handles the entire process from source to build to test to deploy. And that could be another webinar, which is why we don't do it. But Code Pipeline, again, integrates very, very nicely with CodeBuild. And that is it. Thank you, everyone, from attending the webinar. I'm going to be around for some Q&A in the next few minutes if we have time. Otherwise, thank you again for showing up. Bye-bye.